Hello, today we're going to be looking at square root functions, and so I have this equation here, y equals the square root of x. Now I don't know much about these functions, so I can simply make an xy chart to help me out. And I'll start with negative 2, and if I plug in negative 2 for x, well, I get the square root of negative 2. And if I put it on my calculator, it's not going to work out, because if I take the square root of a negative number, we're going to get an imaginary number. If I were to simplify that, it'd be I times the square root of 2. So this is complex, and it won't work for us to graph it because I can't find I square root of 2 on this normal xy coordinate plane. If I put in negative 1, same result. I get the square root of negative 1. This is simply I. This one is also going to be complex. If I put in 0, then I get the square root of 0. That I can do. There is a number times itself that gets me 0, and that number is 0. So there's my first ordered pair. I have 0, 0. If I go negative, that's when I'm going to get imaginary numbers. Those are not going to be part of this graph. Okay? Now if I go to 1, well, the square root of 1 is 1, so that's nice. How about 2? If I put in 2, I get the square root of 2. And that's not a nice number. That's going to be 1.4 something, so let's not worry about that. 3 is not a perfect square, so this is going to give me a bad number. 4, that's nice. 4 square root of 4 ends up being 2. So right now I have 3 ordered pairs here. If I go to 5, I'm going to have to square root that. That's going to be bad. 6 is square root of 6 is bad. Square root of 7 is bad. Square root of 8. How about 9? If I go to 9, square root of 9 is when I get 3. Okay, perfect. So let's try to graph as many of these as I can. 0, 0 is right there. 1, 1. 2 and 3 are pretty tough to deal with. So how about 4, 2? There's 1. And 9, 3, I don't have that on here. But if I go all the way over to 9, 3, it's going to be up here somewhere. So I'm not even going to quite make 3 for my y's as I cross this graph there. And there we are. What I have here, if you turn this sideways, is a half parabola. So we have a sideways half parabola here created from y equals the square root of x. Now this is where some things change for us. Our domain, we realize that we're not allowed to plug in things underneath that square root that are going to be negative because they're going to be complex. So my domain are my x's that are greater than or equal to 0. The range, if I plug in a number that has to be positive, I'm only going to pop out here numbers that have to be positive. So my range are also y's that are going to be greater than or equal to 0. Now to make this a little nicer on ourselves, what I did was found numbers that ended up giving me perfect squares underneath that radical. So here I have 2 more square root functions to graph. My first one is y equals the square root of x plus 2. So let's go ahead and make our xy chart. So we need the number underneath the radical x plus 2 to be greater than or equal to 0 so that I know that when I take the square root of that number, it's not going to be negative. I'm going to have a real number. So if I solve this, that's a greater than sign. So if I solve this, x is going to be greater than or equal to negative 2. So I know that my x's can start at negative 2. And if I put that in, the square root of negative 2 plus 2 is 0. The square root of 0 is 0. Okay? The next thing I want is to make sure that I'm going to get nice, perfect squares for me to square root, because I don't want to deal with any of those terrible radicals. So what's my next perfect square after 0? Well, it's 1. So I want to turn the number x plus 2 into the number 1. And if I solve that, I'm going to get x equals negative 1. And so that can be the number I put in there. X equals negative 1. All right, so I can put that number in. The square root of negative 1 plus 2 is 1. Square root of 1 is 1. So what's my next perfect square after 1? Well, 2 isn't a perfect square, 3 isn't, but 4 is. So I want that number underneath there, x plus 2, to be equal to 4. And so what value of x gets me 4? Well, x would have to be 2. So we go to the square root of them, we do 2 plus 2. Square root of 2 plus 2 is 4. We get 2. All right, 5 isn't a perfect square, 6, 7, 8, 9 is. So x plus 2, we want it to be equal to 9. We'll solve, so x equals 7. So we have 7 in here. We'll do the square root of 7 plus 2. And that's the square root of 9, which is equal to 3. And there we go. So that's a pretty good amount of things to graph. Let's go ahead and put them on here. So negative 2, 0. We have negative 1, positive 1. Positive 2, comma 2. Positive 7, 3, 4, 5, 6, 7, comma 3. Fits perfectly. And there is my graph, the square root function. Okay? Let's look at the next one. Y equals the square root of x minus 5. I'll do the same thing. So if I take the square root of x minus 5, again, I just need these numbers underneath, the x, to be greater than or equal to 0. That's my domain. So I'll start with 0. And if I do the square root of 0, I get 0. But then I do minus 5 for negative 5. No big deal. If I go to the next one, my next perfect square is 1. So I'll do the square root of 1 and then minus 5. Let's erase that and try that again. Square root of minus 5. And that is 1 minus 5 for negative 4. My next perfect square after 1 is 4. So let's break out the green. So we have the square root of 4 minus 5. That is 2 minus 5 for negative 3. And I'll do one more here. I need the orange. 9 is my next perfect square. Square root of 9 is 3. Minus 5 is negative 2. I don't think 9 is going to fit on there anyway, but oh well. So we go to 0, comma negative 5. 1, 2, 3, 4, right there. And I go to 1, comma negative 4. 4, comma negative 3. And then 9 is going to be off the graph somewhere right about there. So there is my square root function. So here for this one, the one we just did, we know that the domain was x plus or x is greater than or equal to 0. The range, here my y values are actually starting down at negative 5. So my range can go from y's greater than or equal to negative 5. Whereas up here my range is the normal y is greater than or equal to 0. And we are done.